Okay, this is the aquaponics system we set up in the school. This is the NFT where the students will put some plants in this net pots using small granites just to anchor so that the plants can anchor their roots, or we use a foam to hold it, allow the roots to come out from here. I'll just put it in here. Okay. Um, this is where the water will be discharged from that pipe you see over there. It's 20 mm drain pipe, and it will flow back to the fish pond, which I'll show you in a minute. Now, these are about 1 inch and each and quarter size granite. That's what we could find. Anywhere between 20 mm to 25 mm will do a good job. This is our shroud, something like this, to keep out the granite and allow water go in. So this is what we have here. This is the magic that does the flushing. If we don't have this in the system, what happens is water fill because water keeps coming in and this will overflow. But there's a pipe in here, 20 mm pipe, you can see here, that sets the level of water just about inch and quarter below this granite, so we don't actually see the water coming up. So that's the mark, you can see that. So this is the height of the water. When the water gets here, she falls into this 20 mm pipe and it creates a vacuum and sucks that water down to about 1 inch and it starts filling back again. So this is a slow fill, fast drain. It drains in about 2 minutes 40 seconds thereabout. So let me put back the bell siphon. Remember, the main purpose of this whole video is to enable a lot of the viewers who wants to do a DIY to understand how the system works. These are local materials you can find in any of your plumbing stores. These are 2-inch cap, this is a 2-inch pipe, this is a 20 mm, yep, 20 mm 90 degree. We use glue, we use the hole saw to make a hole, a 25 mm hole because that's the diameter of the outside diameter of this pipe. Socket it in, use glue and put a 20 mm pipe. So this sets the level of the water. If this is here, the water will drain to this point and takes in air and stop. So the lower it is, the lower the water you want to remain at the bottom of your grow bed. So we actually want about 2 inches of water. That is why we made it 2-inch short to the bottom. It's that simple. You can see the water is coming out to the high point here. That will still flush out in a minute. I will make sure I capture that so you can see the effect. So this is granite. You can either wash it before loading, or you load it and allow the system cycle and wash it out for you. Now we're talking about the water pump here. This is a school. We want to recognize or implement all safety measures as much as we can. Our electricity stops just right there. Every other thing you see here is being brought in by water garden hose or your normal cooking gas hose. It is about 150 psi thereabout. This pump doesn't use more than 2 psi, so even your normal nylon silicone hose will be able to do that, but we're just working with what we have. So the bottom line is this flue you're seeing right here is being provided by a small air compressor over there, which takes 25 watts. That gives up this water. This is pumped about 43 inches below the ground level, and it gives us 350 liters per hour. It doesn't sound that much, but the whole idea is we have a 25 mm pipe over here. Let me give you the shot from behind. Okay, this is a little bit tight. Okay, set this loose. I actually forgot to remove it initially. So this is a 32 mm. This is a 2-inch reduced to 32 mm. to another 2-inch, reduced to 32 mm. That is 50 mm reduced to 32 mm. The water bulbs like it's being spit out by the pressure of water in this pipe over here. Now, let me get down so you can see the pump pretty well. Now, I'm directly under the grow bed. If you look over here, you will see a 20 mm pipe coming directly below the grow bed. Yep, going out to the NFT. If you look here, we have a valve. It's 40 mm valve. I prefer the millimeter because it's easier for me. We use this to drain out any sediment that must have built out in this pipe over a period of time. We just open it up like this, and that's it. And it flush any sediment that must have been picked up here. Okay, want to clean more, we can turn off the pump, open it up, block or seal up the other end from the aquarium with a cap, and use a brush to clean the whole system. And open up the brush, the cap, and allow water flush all the sediment out. So we can do that once every 6 months or so, just to keep the system clear from a lot of sludge building in there. Now this is a 25 mm pipe. This is a 50 mm reduced to 25 mm using some bushings. If you can hear that serious agitation, I don't know if you can hear that. That is water and air being mixed in this pipe. So the whole idea is water comes in from here, from the aquarium, enters through that one-way valve or non-return valve, like some people call it. That is an inch and quarter, and it climbs here, comes in here. Air is being injected here. It builds the pressure. If the air tries to go back with water, that valve closes. It is being forced to shoot out that water here. As that water is being coming out and the vacuum, the pressure is being pushed out, air comes in automatically. So it just keeps working like an internal combustion engine. But this time it pushes out water. So whatever solid that is being picked from the grow bed back to the fish pond and back here, as long as it can fit into this 25 mm, we'll get it out to the grow bed. It's a lot safer. It doesn't clog as easy as the normal aquarium submersible water pump, and it's safer because there's no electricity in the system. So you can see the agitation again. These are locally fabricated material, just to call it a collector. Just to collect the water, goes up, falls down, exits from here, and splits out. One goes that direction, the other one comes here. So we intentionally use the 50 mm so that we won't have this pipe clogging up on us every few weeks or every few months. So we want the system to be almost maintenance free as much as possible. There's a stopper here, we call it a stopper. So that is what stops the excess water from spitting out, over the top here. That's what it does, just to make sure it holds the water but allow air. You can see that effect right now. Now that's it for the pump. Back out a little bit. All right, so this is a siphon, just got started from one of the grow bed. You can see the flow of water. To see it clearly, you can see that. So it's filled up now, and she's discharging that water faster than the volume that is coming in. So that's what the bell siphon does. And so this is what will keep wetting the roots of these plants every 10 minutes or so. We'll time it at 10 minutes 40 seconds for it to discharge this water. And you can see how fast the water is discharging. It's almost at the bottom now. When it gets to that mark, it sucks in air, it stops. There's no moving parts whatsoever in this system. So this is the second grow bed. Still filling up. So you can see the flow. There's some serious flow. Yep. So this is the net we use to scoop out excess feed from the system, allow it dry out before we feed it back to the fish to minimize the waste we are creating in the system. Now, this is the air compressor. I just use this styrofoam to cover it, keep it out from water, but we also have the bottom so that it can take in air and oxygen to cool off, because it's outdoor. These are plastics. You can see some rust over here. We're going to paint this. So this is where we get our power from an uninterrupted power supply nearby, and just to control the pump, came to need to do some maintenance, switch it off and do some maintenance. Now, this is a pipe that takes water to the pump, you see the other time at the back, yeah, and this is a return from the NFT that flows the water back to the fish pond. Now, this is our cover for the fish pond. Water away. Okay, this is a 450 liter aquarium. Nothing fancy, just glass to make it attractive for the students. The water is being fed to the pump from the bottom there, and this is water returning from our filter. Now, we have tilapias in here. We want to just put our air stones here to give them oxygen, so we decide to use that same air pump, that same energy, to design this filter. Now, how does it work? That's the bottom. You see that's 50 mm pipe, 90 degree, to enable suck this solid waste from the bottom. Comes this way, goes like this, goes like this, and is being fed from the bottom of this mechanical filter. Now, what do we have here? There you go. This is a mechanical filter. We have some brush in here, filter brush, about 6 of them, and then we have a net above it, and we have some small granite to keep the net at the base or at the top of the brush. And the water will rise from the bottom from that pipe, and this will trap the solids. We need the water to rise, go in from this 50 mm, exit to this next one, and give us this vortex effect. Okay, and this is an airlift pump, nothing fancy here, just one air stone. And this is an 18 watt air pump over here. She injects oxygen here, sucks the water from the bottom, and it takes it out from here. So based on this flow, we are getting about 1,500 liters per hour on this flow. So we are achieving two things here. We have the filtration going on. The water is being filtered here. Bring out here clear water, inject oxygen, and out you go. With the same amount of air pump, we would have ordinarily put some air stones and just have them buckle up the water. So we said, why do that? Why not add an extra filtration into the system? At the bottom here, we have 20 mm and another 20 mm drain. So whenever we want to clean out this filter, we stop the pump. We use a cap to block the inlet, which is down here. We push this down, something like this, to exit all the water, wash all the filter, and we'll put it back. So that's how the system works. Very simple system, and it's going to produce a lot of food. We have about 20 fishes here, 16 catfish and 4 tilapias. I don't know if you can see them. They're very happy at the bottom. That is the water effect. It's air and water coming out. You can see the current. This is the return of the water from the NFT coming back to the fish pond. So this will give us extra filtration. Whatever escapes that system comes back here, eventually be sucked out from the bottom, back into this filter. We'll get clear water coming out from here. So that's it. That's the system in a nutshell. We can expand the system by using some grow towers later in the future with a submersible pump somewhere here with a timer that will probably lift the water up having drain back by gravity to the granite bed over there and return back here. So that's it. There's the food. I have it put in here for safety purposes. So that's the system. You can see we're having clear water here. So we want to cover it slightly to keep out dust and all. So and these two will be slightly covered later. Just want to do some maintenance here. I have some leakages down here. I want to add some silicone to seal it up. Very minor leakage, but I want to seal it up as much as possible. So that's the system. You can see some fish stocked here. I'm going to scoop them out now with the nets and allow it dry out and get it fed back to the fish later tomorrow afternoon. By then it must be dried. So we're having a lot of sunlight here. Yeah, I know this algae will disappear in a few days to a week. We've had a system like this before. The first few weeks we had algae. After introducing the fish, when the system mature and all the bacteria is kicking, the algae will be reduced. I mean, the water will change completely to light brown. We still have algae from time to time on the glass inside, so we normally use a sponge to just scrub it out and allow the filter to pick out the. We do that before feeding the fish in the morning so that they won't be stressed. Catfish have a tendency to throw up their feed when they are stressed. So, hope you enjoy. Have any question you can ask at the comment. Just to make it clear, this entire system uses less than 50 watts of electricity. Less than 50 watts. This is 15 watts. That is 25 watts. So, and it's very good. I'm really happy with the outcome.